NXP recently launched its solution to fractured ECU development in electric vehicles, the S32 CoreRide platform. It's the industry's first software platform that allows OEMs to combine multiple ECUs and design flexible architectures that support separate vehicle functions. We interviewed Paul Lee, Senior Director of Automotive Ecosystem Management and System Marketing at NXP, and he gives us details on how the platform works, how OEMs and Tier 1s can leverage this to simplify their ECU development, and how it integrates with NXP's existing hardware and software solutions. Enjoy the interview.
The S32 CoreRide platform is the platform we announced. And basically, the platform is a combination of NXP's SoCs, for example, the S32 family, along with integration from our software partners of key pieces of software. So, for example, the OS, the middleware layers of software, pre-integrating those into a solid package and delivering that to customers. One of the key challenges that we see with SDV development is that there's a lot of effort that OEMs and Tier 1s have to go through of integration of the basic software with SoCs in general. So, for example, we have multiple software providers that are doing OS development, for example. They're doing middleware development. They don't necessarily know the ins and outs of our SoCs, and these are very complex SoCs. For example, with networking accelerators, for example, or A accelerators, different types of accelerators to do specific functions and increase system performance. And so what NXP is doing is actually working much more closely with our software partners to do the integration of that low-level software to basically make the silicon run, and really reduce the efforts of the OEMs and Tier 1s that have traditionally had to do this in the past to provide the solution. And so what they can do then is focus most of their efforts on what we consider the value-added software. So it's really about the application software, or it could be higher levels of middleware, but more about the differentiation they can bring from a software perspective to the market.
What sort of problems do they run into if they try to do that software on their own? What typically happens?
Yeah, so from an automaker perspective, for example, when you add, in the traditional sense, when you add a function, you want to add something new to a vehicle, you typically had to have a function that's tied to a piece of hardware, an ECU. And when you want to add that function, then that adds complexity to the overall EE architecture of the vehicle. So you can think about, for example, some of the high-end vehicles have up to 100 ECUs in their vehicle, all tied together with a specific networking configuration. And the complexity of all that integration, plus this specific hardware-software integration that has to happen on that ECU, just can exponentially increase its complexity through the roof. So what we do and try to do is make sure that we're reducing that amount of effort, as I mentioned before as well. So that's one challenge that they have. The other challenge is flexibility and scalability. So scalability in terms of addressing multiple different architecture variants. For example, there could be a low-end variant versus a high-end variant of an architecture because of cost reasons, for example, or it could be across a different fleet. So it could be from a low-end segment car to a high-end segment car. And having the flexibility to allow for function distribution separate from hardware and being able to place those different functions in a vehicle is something that we support as well with the S32 CoreRide platform.
Yeah, that kind of piggybacks on what Jim Farley, the CEO of Ford, said maybe 3-4 years ago. Was basically what you just said. He's like, we have so many ECUs and so many different software, just completely different formats, and it's really hard to wrangle as an OEM, and it's almost impossible to really vertically integrate that, and you're kind of stuck at whatever the Tier 1 supplier says or does. You're stuck with whatever they give you, and it's really tough. So that's interesting to kind of help solve that problem.
Yeah, absolutely. And from a Tier 1 perspective as well, I mean, this platform is also looking to help ease their efforts, because as well with the Tier 1s, again, that low-level software integration with our hardware is a significant effort, and allowing us to provide that optimized combination of hardware and software increase system performance as well. And there's cases where we've seen, let's say, a 30 to 40% increase in system performance by NXP doing that work. Allows the Tier 1 to really focus again on that value-added side of software, the middleware layers, the application layers, where they're the experts.
Are there any core or kind of standout features that you built into it that you wanted to go through?
Yeah, one example is something called isolation execution environments. So this is specific with NXP's hardware and software, where we have actually created hardware mechanisms to allow for hardware isolation within an SoC. And that hardware isolation goes all the way down from, let's say, the pin, all the way up to the core, all the way up to the memories that's specified by the user. And this isolation execution environment allows for ECU consolidation. So you can think about one application that was running on one piece of hardware in the past, combining with another application. And these applications could be, for example, safety critical applications. And in the industry, it's ASIL-D, right? It's the highest level of safety critical applications. And if one of those applications fails, you don't want that application to take down the full SoC, for example. And so in some of our SoCs, you could have maybe, let's say, 16 critical real-time applications that are running all in parallel. And the isolation execution environments actually create a separate piece of, let's say, environment on the hardware, on the SoC, that, for example, if one of those safety critical applications fails, it does not affect the other applications. So, if something did happen on, I don't know, let's say you have a body control module or a steering wheel switch or something like that, and that failed, it wouldn't affect your suspension control or chassis control, right? That's really affecting the performance of the vehicle. So that's one of the unique features that we have is really this isolation execution environment that allows for that application separation.
Is the S32 core platform, that's not new, that's built on some other families previously, is that right?
Yeah, so the S32 CoreRide platform is actually built on our S32 processing line. And our processing line ranges all the way from standard MCUs that are used in body applications. So you can imagine like a windshield wiper application where you have to control a windshield wiper, or even opening or closing a trunk or a sunroof, for example, all the way up to high performance SoCs that are a combination of multi-core real-time functions. So for example, our S32N, which was recently announced, has up to 16 real-time cores, R52 real-time cores, to allow for high performance real-time. And that allows, again, as I mentioned, this ECU consolidation, right? That really does drive BOM cost savings. It drives weight savings, for example, and enabling that consolidation to actually take place into one SoC. So, we have different S32 processors that range all the way from that low end microcontroller controlling one function all the way up to this, high performance MPU, excuse me, that's, has that 16 core Cortex R52 functionality. And in parallel with that, we have also our networking products as well that allow for LIN, CAN, multi-gigabit Ethernet, along with our system power management as well. And so the combination of all three allows us to have, let's say, the platform capabilities to work together with our software partners to really create a system solution.
We had a reader ask, does it have open source capabilities?
So when we talk about open as part of the platform, what we mean is that open is open to multiple partners to work with NXP. So, for example, there's some providers in the industry that have a very prescriptive, specific implementation of software hardware combination. So that could be, one specific real-time OS plus one specific POSIX OS, for example, that can only run in combination with the SoC. For NXP and with the S32 CoreRide platform, we are open for all of our partners to work with us and provide the optimal solution based on the customer's preference. So depending on what the OEM or the tier one wants as those specific software partners, NXP is open to work with them together. And so that's what we mean by open platform.
Is this product available for order now, or if not, when we have it launched?
Yeah, so we're working with early alpha customers right now on the S32 CoreRide platform, and it's based on customer requests, and working with our sales team, we can discuss any opportunity with customers to engage with the S32 CoreRide platform.
Any other features or benefits or things you want to run through with the product?
Again, I think it's really about that combination again of the hardware, software, really optimizing the performance, reducing that integration, and then in combination with our next generation high performance real-time processing, the S32N, for example, we can enable that central compute consolidation of multiple functions, and that's a big deal to really drive the industry forward in this consolidation, and really making that SDV a reality, because once you can start combining functions at the same time, you can separate the function from the actual underlying hardware. And that separation of the function from a software perspective allows you to be flexible. It allows you to have upgradability. It allows you to potentially move a function that was living in one module, let's say a zone module, to a central computer. And so that flexibility is also very key to make sure that OEMs and tier ones have that flexibility to optimize their architectures. And it doesn't have to be during SOP, or excuse me, during production, but it could be after SOP when they're doing an OT upgrade, for example, and they want to implement something new. So it's really unlocking that capability of what a true SDV can be by allowing for that software upgradability, flexibility, and movement of functions.
Do you have any idea of what's coming down the pipe in regards to this product? Maybe the next few years, where do you see this going?
Yeah, so we continue to have a great roadmap of products on the S32 family in particular. We announced the S32N family, and there'll be multiple variants of that S32N family to address multiple central compute use cases. We're also working on multiple other devices on the S32 family focused on real-time control and zonal control as well. So we have an exciting roadmap of devices and software to really help the industry, and looking forward to sharing more of that as time comes.
Well, thanks for your time.
Appreciate it. Thank you very much.